How's it going, everyone? Welcome. Evolier Gonzalez. That's right. So, what I want to quickly explore on the data fetching, which is a topic that caught me by surprise, especially because I didn't know how these things work, or at least the history of this, right? And this is part of the model from a React course taught by Josh Comeva, a software engineer that previously worked at Khan Academy, one of the largest companies, educational company to ever use React at scale, right? And so then he went through that company to help him build this kind of courses, right? And then he went through Gatsby, and currently now he's here actually is creating these kind of courses. So one of them is the React, and the other is the JavaScript for CSS for JavaScript developers. So on that topic, all right, especially on the React themes, I have recorded myself exploring it, and I'm going to do that as well, but particularly is to explore the spec, the HTML spec, as well as everything related to it. And that is the CSS as well, the JavaScript, TypeScript, and SQL. All right. So, but in today's video, I just wanted to briefly describe is how do we get here, particularly on this topic called data fetching, which is one of the things that we as developers are going to ask a lot, especially if you want to implement some behaviors in your application. So for example, hey, I just want to now my app handle authentications, but I don't want to create my own. I want to rely on third-party services. So you can go with Okta or OAuth or Clerk or any of these service providers. Okay. Sometimes you want to now is use a server to store your data, right? So a database. So in those cases, you might want to, instead of relying on your own, you can rely on other services. So for example, is on the AWS or the Google Cloud services, right? So whether if you are storing that in an organized way or in a structured way, using is the SQL database, whether it is Postgres, SQL, or MariaDB, Redshift. I make a pause here because I'm trying to remember is the SQLite, that's right, which is heavily used on web applications and mobile apps, okay? Or you want to store that on a different, or using a different structure, that's a JSON, right? So you have now MongoDB, for example. In any of those cases, so when you started to understand that you need to delegate your the functionality of your application to somebody else, a third-party service, so you are now putting all the risk and all the heavy lifting in that particular company, right? To handle that in the most effective way possible. So again, specialization is something that is very, very effective, at least in this kind of economy at scale. But what the other thing that is very effective is to understand the overall architecture or the understanding of how all of these things work. So again, I mention is this because most of the time or this kind of applications actually needs to interact with external services. So a good example is that when I work for a particular company in the real estate, they need is to their listing make that available across different social media applications. So again, these companies that they create now their entire products and ecosystems, Facebook and Google, right? Now they needed to, or in order for you as part of the real estate agency to have access to their services, you need to interact through them via an API. In other words, you need to send that information or fetching that data using a particular way, a particular protocol. So in this scenarios where you are going to do that a lot of the time. So in order to understand how do we now share data in the early days of web development, so you have now a particular element that allows to do that for us. So what I'm going to do is to read about that spec, right? But this has come from the WAT-T working group, right? Is the web, let me see if I remember this. This is maintained since 2004, right? The Web Hypertext Application Technology Working Group is now, initially was a bunch of people, smart folks, that works in Opera, Mozilla, and Apple, and they wanted to come up with some sort of way to standardize the development of these documents, HTML documents, right? Which is a very convenient way of how you can now send these documents in these particular structures across different computers. So you can imagine that how do you share now newspaper, which is something that a lot of people, they don't know how to do that, or they don't even know what the newspaper is. But yes, trust me, there was a time when you have these physical papers, right? Pretty much like books and stuff like that, right? You have these physical papers, right? And then you somehow you want to share with somebody else. Think of this like a book, all right? You want to share now this book with somebody else, but unfortunately, this person is 1,200 kilometers. So unless you have now a nice vehicle, whether it's a car or a helicopter or an air flight ticket, right? In those cases, you'll have to physically go into that and share that documents. So why am I mentioning this? Is because the origins of the HTML and HTTP, particularly the origin of this document and the protocol in which we exchange those documents using now the HTTP, and this protocol that was developed by the CERN, the Comité Européen pour la Recherche, which is a commit, is an European commit for the nuclear research back in the 90s, where they have that particular need. Scientists back then have that needs. That, hey, how can we now share these particular documents across physically or geographically separated places here, right? And this way of transmitting this kind of documents was made possible because we have now this thing called the internet, which is just a collections of all of these different computers that are connected into this network, where they can now transmit data here, known as the transmit control protocol, right? And if you want to locate computers in this network, you use now a particular protocol, which is the IP, right? Internet address. So I mention all of this because the developing of these kind of techniques or these protocols, particularly for the computers, it comes from the interest of the military to invest in what smart folks back in the 50s and in the 60s were doing with these things called computers, right? And how now they communicating and to exchange data across different computers, right? And this was also as a response, at least this initiative of what happened in 1957 when the Russians put the first satellites on our heads, Sputnik 1. Okay, so that caught Eisenhower by surprise, and that's when you create this this agency, the DARPA. So you can see here, most of these technologies that we can now interact and we give that by settle, all of this was invested and funded by military contracts. So things like the GPS, HTTP, TCP, and IP, and also the motor computers as well. All of this was a ton of efforts and funding by military contracts. So this, despite that in today's video or in our daily life, that is, we give that by settle, right? And we give this as a tool for peace and so on and so forth. It didn't come from that place. It comes from this military budget here. So, in any case, I do this. I do this kind of stuff because I do think that it's quite important to understand how do we get here, because we don't put a veil in our eyes when we are developing applications in this landscape, okay? And not to mention in the software realm. So, in any case, this way of sending data in these documents, and this is why I would love to read about the HTML living standard, particularly the introduction and the common infrastructure, okay? It was made possible by all of this effort, from all of the heavy lifting of all of these people that make this possible, starting from I will say Einstein, and then Claude, and all this long lineage of people that they have worked toward these devices, right? From the early mathematicians in Egypt all the way down onto this day. Now, because the HTML is this particular document, all right, that was developed by Tim Berners-Lee at the CERN, right? Here, luckily for us, we have now this living standard that describes a little bit of the history of this. So that's what I'm going to do right now, and then describe is the possible or the original way to fetch data in this document. All right. So, real quick, here this is the HTML, and the HTML here is organized in this introduction and the common infrastructure. Okay. This introduction is really describing is where the HTML comes from, what are the things that you need to know in order to understand this, these living standards. That you must be familiar with these terminologies. What is a web IDL? Particularly, what's the DOM? So what is the DOM? Is the event model. The DOM is describing as the event model. Let me see if I can look at this real quick. The DOM, that's right, the DOM spec from here. Okay, so the DOM defined is the platform neutral model for events, aborting activities, and node tree. All right, so it's important for you to understand is the DOM understanding is the web IDL, which is the APIs that this web platform expose. So you as an author of these HTML documents, you can have access to via, not through the document, but through the language, particularly JavaScript here. So what is then an HTTP, which is the protocol and how you can transmit this how you can transmit these documents here, the core semantic of the HTTP protocols here, semantics and caching. Those semantics are expressed on the wire in three ways: the HTTP 1.1, HTTP 2, and HTTP 3. Most of the time I am quite familiar is with the HTTP 1, right? Internet standard. And as you can see, this hypertext transfer protocol is a stateless application level protocol for distributed collaborative hypertext information system. And here is describing this notion here. So the distributed, the collaborative, and the hypertext information systems here. And this hypertext information system is those that are available for exchange these documents. So this document specifies the HTTP 1 message syntax, message parsing, connection management, and related security concern. Four things that is describing this HTTP here, right? The message syntax, message parsing, connection management, and related security concerns. So far we have looked at here at, if you read about this is an internet standard track document. This document is a product of the Internet Engineering Task Force, the ITF-T. It represents the consensus of the IETF community, and it has received public review and has been approved by approved for publication by the International Engineering Steering Group. Further information in the standard on Internet Standard is available in the section 2 on this. This is a copyright notice, okay? So IETF trusts that the persons identified as document author all right reserved. So, and then you got part of the introduction here. The Hypertext Transfer Protocol, HTTP, is a stateless application level request protocol that use extensively semantics and self-descriptive message for flexible interaction with network-based hypertext information systems. There's a lot of jargon here. There's a lot of jargon. But it says that this protocol doesn't store any information at the application. It's like it doesn't store any information, and it is at the application level based on this request response protocol. I ask for something, you give me something, right? That use extensively semantics, okay? It have a lot of way to define this protocol of communication, this request and response, and self-descriptive message for flexible interaction with network-based hypertext information systems. This network-based hypertext information systems, it is those applications that allow you to transfer these documents, hypertext documents, and use this protocol here. So this document is defined as this document, okay, HTTP semantics, and HTTP caching, right? So this document is specify how HTTP semantics are conveyed using HTTP 1.1, message syntax, framing, and connection management mechanisms. Its goal is to define the complete set of requirements for HTTP 1.1 message parser and message forwarding intermediates. So these three aspects here, the message syntax, framing, and connection management mechanism, right? Some of the time I am quite familiar with the message synthesis, but it's also describing is the framing here. And not to mention is the connection management mechanism. This I'm not quite familiar with, but I am quite familiar is with the message syntax. My question is that, is this document describe things like that, like framing, connection management mechanism? And where does it describe this? It is the goal is to define the complete set of requirements for HTTP 1.1 message parser and message forwarding intermediates. These documents obsolete the portion of RFC 7230 related to the HTTP 1 messaging connection as it is. So again, I am not going to look at all of this, right? Perhaps just to describe if that this syntax or the requirement notation for the syntax as the message format, message parsing, and HTTP versions, request line, right? Exactly. So the request line and the methods or the anatomy of this request and response, right? So in the request you have now the methods, you have the request target, and reconstructing the target URI. All right. So where you want to send now this, all right? Some of the status line, field syntax, message body, transfers coding, handling incomplete message, connection management here, and enclosing message as data, as well as some security considerations on this, right? And this is quite interesting here, because on this connection management is describing is that HTTP messaging is independent of the underlying transport or season layer connection protocol. HTTP only presumes a reliable transport within order deliveries of the requests and the response in order delivery of the response. The mapping of the HTTP request and response structure onto data units and underlying transport protocol is outside of the scope of this spec. Because it's describing is the mechanism here. This is the specific connection protocols to be used for an HTTP interactions are determined by the client configuration and the target URI here. For example, the the specific connection protocols here are determined by client configurations and target URI here. For example, the HTTP URI scheme indicates a default connections of TCP over IP with default TCP port 80, but the client might be configured to use a proxy via some other connection port or protocol. But again, it's up to the client here. Usually these clients, it is an application that use now these protocols to transmit this data. HTTP implementation are expected to engage in connection management, which include maintaining the state of the current connection, establish a new connection, or reusing an existing connection, processing message received on a connection. Look at this. So HTTP implementations are expected to engage in connection management, which includes maintaining the state of the current connection. Maintaining the state of the current connections, establishing a new connection or reusing an existing connection, processing message received on a connection, and detecting connection failures and closing each connection. Most clients maintain multiple connections in parallel, including more than one connection per server endpoint. And this is quite interesting because that is actually something that a lot of the time here we are at 2026, we are suffering from. And that's why we have now HTTP 2 and HTTP 3. Most servers are designed to maintain thousands of concurrent connections while controlling request queue to enable fair use and detect denial of service attacks. But again, this spec is describing, at least in the connection management, is that the protocol implementations, they are the implementators of these protocols. They are expected to engage in the connection management, that is, maintaining the state of the connections, establishing new connections or reusing an existing connections, processing messaging received on a connections, and detecting connection failures and closing each connections, while also maintain multiple connections in parallel. It is beyond the scope of this specification to describe how connections are established via various transport or season layer protocols. Each HTTP reconnection maps to one underlying transport connection. But this is exactly what you're starting to see here, right? Establishment. It is associating a response and request, persistent, right? You can persist those, so those connections must persist. Okay, you can persist that by using the keep alive mechanism. Retrying requests, interesting. Pipelining, concurrency, right? You can maintain several connections in parallel, right? Failures and timeout, right? Tear down. If you want to close the connections to that, right? Mm-hmm. Yeah, the connection here, you can close that connections, all right? And enclosing metadata as data. It's like how you're going to process this type of data. Media type application, HTTP, and some security concerns as it is, right? But again, with that, what I just want to describe is the overview of the HTTP, all right? By looking is that what is the HTTP is based on, which is this stateless application level request response protocol, right? Request response protocol, that it has a lot of semantics, okay? In self-descripted message for flexible interaction with network-based hypertext system as it is. So you have now this reference here, the normative reference. So you can take a look at that more in depth, right? All of this, even Bernstein described as the URI, holy moly, right? Exactly, which was all of the things that was initially used for that. I don't think now is this being updated? January 25. Yeah, but that has not been updated that much. And they don't describe is, for example, the URI here, or another word is the URI living standard, right? The URI living standards here. Oh, exactly. So the URI living standard is not described by the web. Okay, yeah, that's another team. Okay, got it. Makes sense. Mm-hmm. Okay. Okay, but that is it, right? Normative reference, information reference, and a collection of the appendix as it is. So that's the semantics here, right? And right now this is June 2022, right? So what I have looked initially was the first version, which of course has been updated, right? 1.1. The other is the HTTP 2, right? And this specification describes an optimized expression of the semantics for that. HTTP 2 enables a more efficient use of network resource and reduced latency by introducing field compressions and allowing multiple concurrent exchange on the same connections, right? Mm-hmm. And these documents obsolete is the RFC 7540 and 8740. So here's the introduction here, right? So the performance of application using the hypertext protocol, HTTP, is linked of how each version HTTP use the underlying transport and condition on which the transport operates. Making multiple concurrent requests can reduce latency and improve application performance. Wait, what? Making multiple concurrent requests can reduce latency and improve application performance. Exactly. HTTP 1 allows only one request to be outstanding at a time of a given TCP connection. HTTP 1.1 add request pipelining, but this only partially addresses request concurrency and still suffer from application layer head of line blocking. Therefore, HTTP 1 and HTTP 1.1 client use multiple connections to a server to make concurrent requests. So in other words, if you want to make concurrent requests from the client to the server, they have to create multiple connections at the server. Mm-hmm. Client use multiple connections to a server to make concurrent requests, right? Furthermore, HTTP fields are often repetitive and verbose, causing unnecessary network traffic as well as causing the initial TCP congestion window to quickly fill. This can result in excessive latency when multiple requests are made on a new TCP connection. HTTP 2 address these issues by defining an optimized mapping of HTTP semantics to an underlying connection. Specifically, it allows interleaving of message on the same connection and use an efficient coding for HTTP fields. It allows prioritization of requests, letting more important requests complete more quickly, further improving performance. Interesting. Two things here. So you have now a priority of requests. Okay. And is defining an optimized mapping of HTTP semantic here. The resulting protocol is more friendly to the network because fewer TCP connections can be used in comparison to HTTP 1. This means less competition with other flows and long-lived connections, which turn leads to better utilization of available network capacity. Notes, however, that TCP head-of-line blocking is not addressed by this protocol. Finally, HTTP 2 also enables more efficient processing of message through the use of binary message framing. So there's a couple things that this protocols has improved, all right? Is that you can now have a priority queue of requests and improve the processing of the message through the use of binary message framing here. This is an HTTP 2 protocol overview. HTTP 2 provides an optimized transport for HTTP semantics. HTTP 2 supports all the core features of HTTP, but aims to be more efficient than HTTP 1.1. HTTP 2 is a connection-oriented application layer protocol that runs on a TCP connection. Okay, the transmission control protocol. The client is the TCP connection initiator. Exactly. And the basic protocol unit in HTTP 2 is a frame. Okay, the basic protocol unit in HTTP 2 is a frame here in 4.1 section. Frame here. The length is 24, type, flags and reserve, and string identifier and frame payload. Okay. So the basic protocol unit is a frame. Each frame type serves a different purpose. For example, headers and data frames form the basis of the HTTP request and response. So you can send now headers and data, right? Other frames types like settings, window update, push promise are using support of other HTTP features. So this push promise is part of the frame here, right? Interesting. Push promise here. Okay. Okay, push promise. Multiplexing of requests is achieved by having each HTTP request response exchange associated with its own stream. So in this case, multiplexing of requests is achieved by having each HTTP request response exchange associated with its own stream. Streams are largely independent of each other. So a block or stalled request or response does not prevent progress on other streams. Okay. Effective use of multiplexing depends on flow control and prioritization. Flow control ensures that it's possible to efficiently use multiplex streams by restricting data that is transmitted to what the receiver is able to handle. And then you have prioritization. Ensure that the limit resources are used most effectively. This revision of HTTP 2 deprecates the priority signal scheme from. And HTTP 1 fields used in a connection can contain large amounts of redundant data. Frames that contain them are compressed in section 4.3. And this has especially advantage impact upon requests cited in a common case, allowing many requests to be compressed into one package. Finally, HTTP 2 adds a new optional interaction mode whereby a server can push requests. Interesting. A server can push response to a client. This is intended to allow a server to speculatively send data to a client that the server anticipates the client will need, trading on some network usage against the potential latency gains. The server does this by synthesizing a request, which is sent a push promise frame. The server is then able to send a response to the synthetic response or the synthetic request on a separate string. And this is where this notion of string kicks in, the ability that the server can now push data, not only the client. Okay. Interesting. And the push promise here. Interesting. And document organization as it is. Starting HTTP 2 covers how HTTP connection is initiated. The frame section 4 and stream in section 5 layers describe the way HTTP 2 frames are structured and form into multiplex streams. Frame section 6 and error section 7 definition include details on the frame or an error type using HTTP 2. HTTP mapping section 8 and additional requirement section 9 describe how HTTP semantics are expressed using frames and streams. But is this notion here? First is describing how this connection is established. What is the notion of the frame and the stream? Okay, that describes the HTTP 2 frames and the structure forms the multiplex stream here. That is quite interesting in terms of reading about this. So you have the protocol overview starting the HTTP 2, the frames, the streams and multiplexing here, and also the flow control that you can have here, again, for the implementators. Okay, the prioritization and how you're going to handle those errors here, as well as the frame definition here, right? Data, headers, priority, RST stream, setting, pin, go away, window updates, and HTTP semantics in HTTP 2. HTTP fields, HTTP control data, server push, the connect methods, the upgrade headers, example, simple REST. Okay, now this is a couple examples here. This section shows HTTP 1.1 request and response with illustration of equivalent HTTP 2 request and response. Headers, all right. This is the end of a string, end of the headers, the methods. Okay, how now this going to look like, bro? Holy, that's my bene. Single request. How this going to look like? Hey, the method, the schemes, the authority, the pass, host, and accepted. How you going to look at the response, header and the string of the header, the status, if you have no text, and the expiration, and complex requests here, right? And complex requests, you are sending data, for example, in a post here. Post research to be, say headers, and streams, end of headers, and the methods here, right? Method, authority, path, and scheme here. Or if you are now sending binary data, continuation here. Content image, host, and content length here. Data and the stream, binary data. Response with body, right? And then you have the binary data, right? Interesting. Informational response. How are you going to receive that, right? The information response or the 200 response on the data on the headers, and the HTTP 2 connection and the connection management, connection reuse, and use of the TLS features here. Okay, and then the other is the HTTP 3 here, bro. The quick transport protocol has several features that are desirable in a transport for HTTP, such as stream multiplexing, per stream, stream multiplexing, per stream flow control, so you can now have control per streams, and low latency connection establishment. This document describes a mapping of HTTP3 semantics over quick. These documents also identify HTTP2 features that are summed by quick and describe how HTTP2 extension can be ported here. So you're starting to see the idea behind this, right? And on which proposals, what they allow you to do. So in HTTP 1, you don't have the ability to send data to the client. This is on the HTTP 2, all right? When you have now this notion of this. Interesting. Got it, got it, got it, got it, got it. And then the core semantics of the HTTP protocols are defined here. Whether it's the semantics, right? Whether it's the semantics, and in the semantics is describing is stuff like that. All right, let me see if I can read the introduction here. This is part of the HTTP semantics, not the spec, and the other is the caching here. Okay, and in the semantics is described is this, right? History and evolution and core semantics. So I'm gonna leave that as it is because I'm going to expand that in another video. That'll be all. Take care.